chapter R, which is all reviews, but I did not assume that you remembered anything. We went through everything that we needed, and hopefully start chapter 1, which is basically the calculus part of this class. So in the last section of the review that we have to look at, we're looking at nonlinear functions or models. And there are a few functions that I would like to refresh your memory on. I'm just going to simply graph them, and if you have any questions, let me know. So one function is the radical function, the square root. So can anyone give us the domain of this function? Can anyone give us the domain? So let's go back. As we said, with radical functions, if the index is even, we always have to make sure that the quantity, the radicand, the quantity under the square root must be. If the index is odd, then we have no issues. So one more time, can anyone give us the domain, please?
0.
Say it again.
0.
The domain. Domain. In other words, when we ask domain, we're really asked, what can I plug in so that the function exists? What can I plug in?
Is it bracket 0, positive infinity?
Excellent. Thank you so much. So this function can be evaluated from 0 to infinity for any possible real number between 0 and infinity. Awesome. So therefore, the graph looks like this. This is the graph of the square root of x. Here's another graph that is important. Can anyone tell us what type of function this is? As you notice, these are the simplest. We call them base or basic functions from that category. From the category of the square root, this is the simplest. From this category, this is the simplest. Can anyone refresh our memory? What is the name of this function? What type is it? How do we call this one?
Is it a radical function?
But does it have a radical? I will say yes if it has a radical. But does it? So when you identify a function, read it. So when I read this one, I say the square root of x. So what can it be? What function is this?
The square root function.
Square root function or radical. Now let's read. 1 divided by x. What can it be? We looked at it last time.
Is it a rational function?
Thank you. It's a ratio. Thank you. Rational. So the rational function looks like this. We're going to graph several of them later on. But the simplest, the base function. Okay, I forgot. Sorry, I'm rushing. Domain, please. Can anyone give us the domain? The reason I'm not using a table of values is because these are basic functions, and we are looking at the shape to remember the shape. Sorry, I interrupted you.
Is it 0?
So the question is, what can I plug in it, not what I cannot plug in it. You may want to say, well, you may want to
Infinity to positive.
say it again.
Negative infinity to positive infinity?
What?
Or to 0?
Yes. Then?
Union.
Exactly.
0.
Yes,
Zero to
indeed. In other words, yes. So you are correct. First of all, I would say to myself, what is the value or values that I cannot plug in here? And obviously it's 0. It's 0 is the only one. And then I'll say, okay, then, knowing that x cannot be 0, then what x can be? Well, bottom line, anything but 0. So this is a very special function, very important function. So it looks like this. I'm going to come back to it. As I said, hopefully we'll get to chapter 1 immediately. So this is y equals 1 over x. Notice what happens here. As x goes to infinity, the function values get closer and closer to 0. As x gets closer and closer to 0, look what the function is doing. Meaning, as x gets closer and closer to 0, the function approaches infinity. On the other side of the y-axis, as x gets smaller to negative 10,000, negative 1,000,000, negative 10 million, the function values get closer and closer to 0. Now, as x gets closer and closer to 0 from this side, the function values get closer and closer to what? Closer and closer to?
0.
So as x gets closer and closer to 0, the function values do this. Zero is here. Look where the function values are going.
Negative infinity?
Exactly. This is very important concept. One more time. As x gets closer and closer to infinity, who can tell us again where will the function values go? As x gets closer and closer to infinity, the function values get closer, and you have to read from the y value, right? From the y-axis. The function values get closer and closer to
0.
Excellent. On the other side, one more time. As x goes closer and closer to negative infinity, the function values get closer and closer to what value?
0.
Exactly. One more time from this side. As x approaches 0 from this side, the function values do what?
Negative infinity.
Negative infinity. It's a very important concept. We need this for the next step in this class. Okay, there is also something called, can anyone tell us what this is? Read it and you will know what it is. It's the
Absolute.
exact absolute value function. Well, this looks like a V. Again, is the simplest. They're all basic functions in each category, simplest possible. So here it is. Exactly, these are equal. It bisects the first quadrant right in the middle, in other words. Same thing. So this is f of x or y equals the absolute value of x. Okay. There are other functions like quadratic that I would like to refresh your memory on. So that's my page 2. Quadratic. So f of x equals x squared. Quadratic. This is the simplest possible quadratic function. And I hope everyone remembers its graph. This is its graph of the quadratic function. It has a vertex at the origin. The vertex S is at the origin. One other function I want to refresh your memory on, which is the cubic function. So please remember, graphs these several times with your calculator if you want, or in any other way, so you remember the graphs. They're very important. So let's say cubic. So f of x equals x cubed. Cubic function. Very important function. How does it look? Like this. Notice that I'm not graphing a cross like this. I'm graphing a slow cross. Slow cross. It's still 1 point, of course, but it's a slow cross, not a direct cross. It's not like this. It's a slow cross. So this is the graph of x cubed. I'm exaggerating it a little bit just for you to. The other thing that I'd like to refresh our memory on is the quadratic formula. Anyone remembers the quadratic formula? So let's look at an equation. So I want you to pick an equation. I'm going to share my screen. I just realized that I forgot to click on the send email. Okay, I wrote it, but I didn't click on it. Okay. So this is page 60. Okay, I am going to share my screen. Okay, so let's solve any equation from here. You choose. And then we're going to look at some domain. As you see, the domain is super important. So let's quickly solve a quadratic equation. Can anyone pick, or I will?
Can we do 41?
Yes. So 41, that is on page 60. And we picked 3y squared plus 8y plus 2 equals 0. I'm just going to refresh your memory on the quadratic formula. The quadratic formula can be used only if I have a number times the variable squared plus a number times the variable plus a number equals 0. This can be missing, this can be missing, but this one cannot. In other words, because that will not be quadratic. So a cannot be 0. What I'm saying here is that the polynomial, quadratic polynomial, has to be presented in descending order, and I have to have 0 on the other side. This is mandatory. Otherwise, I cannot start the quadratic formula. And the quadratic formula states that in this case, y equals, you can remember it very easily like a tune. Negative b plus or minus the square root of b squared minus 4ac over 2a. So I have to identify next that this is a, this is b. Numbers are taken with their sign in front. So this is the b. This is the c. And of course, this is the a. Once I identify them correctly, I just put them in this formula and perform the operations step by step. Now be very careful. Make sure that this is never a negative number. No matter what b is, when you square it, you get a positive number. I've seen in work something like -4 minus, that's not possible. Because whatever b is, when you square it, this can never be a negative number. The answer underneath could eventually be a negative number, that's possible, but not the beginning, not this number, because it's whatever squared. So when we write the quadratic formula for this problem, we write -8 plus or minus the square root of b squared, which is 64, minus 4. I like to at least multiply a and c, so 3 times 2 is 6, divided by 2 times a, which is 6. And then you can plug in the graphing calculator, this. I will show you also the other option, which you can use. I'm fine with that. I don't want to make a big fuss out of quadratic formula. Absolutely not. So it's tedious. You have to be very careful how you enter it. Again, do not do this arithmetic step by step. You introduce more error, and it's more tedious and more difficult. So we have negative b. I'm sorry, negative 8 I meant to say, plus the square root. In parentheses, I have a special attachment to parentheses. Minus 24, close. Come outside, close. Divide by 6. I get whatever. I recall the previous entry, and I just overwrite the plus, make it into a minus. So I got both solutions. So one of them is, and depending on how many decimal digits we need, 0, negative 0.279, and the other one is negative 2.387. In this class, as I said, I don't care for the quadratic formula that much. You can use apps. You go to number 9, which is polynomial root finder. You select, the order means the degree. We're selecting 2 because it's degree 2. You enter the coefficients carefully, 8, and you enter 2. And you just click on solve, and you solve this equation. I'm fine with this. It's fine. Again, I don't want to go back to arithmetic. There is no point. Now, any questions on this? Now, going back, I would like us to choose something like this or something like this to determine the domain, because this is very important. Anyone would like to choose from 25 through 34, or I will?
Hmm. 27.
27 it is. Okay. Okay, we already did this, but that's fine. So y equals negative 2 over x. Can anyone tell us the domain of this function? What values we can plug in this function?